temporal networks. Okay, great tools and great system for modeling interaction because they consider time, and considering time is important because with them we can understand better the temporal feature and structures of the networks that might influence the dynamics on top of them. But there is a big con. Temporal networks can be highly dimensional objects. And what I'm going to show you now is that using some dimensionality reduction techniques can be a good way to represent networks while considering their temporal and structural features without the burden, let's say, of the highly dimensional part. So what I did is develop a method that we call web-to-back, and it led us to have a temporal network, and from a temporal network, having a temporal network embedding, and I will show you very briefly the steps of the process. So starting from a temporal network, we can define an event as a temporal link, basically. So interaction between two nodes at a given time. And on this information, we relied to build a weighted event graph that is a static representation of the temporal networks. And to do so, we use as nodes the events previously described, and a link between events is we put a link between events if the events are adjacent or are sharing at least one node, as I wrote there. And once we had this static representation of the temporal network, we could embed it using word-to-back, basically. So I don't know if you're familiar with word embedding, but we simply sample every events in our static representation, and we sample it with past and future events, and we rely on the learning of the word-to-back as in text. Events that have a similar context will have also a closer distance in the embedding. And so following this process, we arrive to a representation of the temporal network such as shown in this plot. So each point here is a representation of an event in the embedding space that is basically a space vector of 3 dimensions. And each event is color-coded by the time underlying in the single event. And as we can see clearly from the plot, our method is able to capture the time evolution in the temporal network. Okay, so just to have an overview of this temporal network was a contact temporal network based on interaction in a conference. And if we want to add some extra methods to for the dimensionality reduction of a temporal network, let me show you another thing. So we are talking now about tensor factorization in a temporal network, and we now consider temporal network no more as an edge list with a time step, but a temporal network as static snapshot varying in time. So given that, we can represent the temporal network as a tensor, and given this tensor, we can have a low dimensional representation of the temporal network using tensor factorization. And what we did with that is using a low rank approximation, so keeping the dimensionality of the final representation very compact, and with a constraint on the elements of these two matrices that compose the final representation of temporal networks, with a constraint on non-negativity because of the interpretability of the factor. Of course, we need to understand that every component here is represent the activity of each node of the original temporal network in the final representation. So the activity cannot be negative, and that's why we impose the non-negativity constraint. Okay, say that we can derive from this representation a belonging of each node in the network to a certain component. We can call it community activity detection for once. And we can have something like that. So each event that we derive from the previous temporal network embedding are color-coded by the belonging of a certain component or mesoscale or community, as we want to call it. And we can see again that not only the temporal features of the temporal network are learned and included in the final representation, but also the temporal structural features are included in this final representation. So just to have a quick overview of both the method, we can safely say that this dimensionality reduction technique can work pretty well to define and learn the temporal and structural feature of the original temporal network, without, of course, the burden of the high dimensionality of the network. Okay. So this design for a compact representation work, and it captures local properties. If you are interested to have a deep dive in this, I put you here a QR code that links you to the paper. And this is something I worked on during my PhD, but then I decided to pass to something more applied, still using modeling and on networks and on data science, but I wanted something more applied to real world, let's say. And that's why I was driven during my postdoc to work on misinformation and polarization on social media, on the specific issue of climate change and how the debate about climate change are impacted by the event of an hurricane. And I will explain you very briefly what we did during this project. So I don't need to convince you that climate change is a very important issue nowadays, and it is pervasive across environmental policies, political debate, most of all public opinion and public debate about it. And we know from literature and also from experience, you better than European, let's say, that major impact of extreme weather events such as hurricanes can change notably the perception of climate change. So we were wondering how much and in which term an hurricane can impact the public attention toward climate change. Okay, so what we did is collecting data from Twitter, basically, and we rely on two different databases. One, we collected all the tweets from 2010 to 2022, mentioning the biggest 18 Atlantic hurricanes in this period. And from these 36 million tweets, we recover 205K news articles. And this database was used to investigate the themes discussed around climate change and hurricanes, and the terminology used to do that. And the other database, we collected all the tweets in the same period mentioning climate change. No specific relation in this database about climate change, and no specific relation with hurricanes in the other dataset. This is very important. And on the other side of the dataset, we try and monitor the area affected by the hurricanes and the mention to climate change on Twitter before and after the events of the hurricanes. Okay, so talking about topic analysis on the first database about news, we could discover that climate change here is one of the most important topics discussed, apart from the specific one related to hurricanes. And this is not obvious, as I told you, because the news we collected are related directly to hurricanes, not specifically to climate change. And once we investigated the terminology used in the news to speak about this topic of climate change, we discovered this. Okay, so we divided our news outlet in reliable and unreliable using the NewsGuard database. That is a database cured by journalists all around the world and is continuously updated. And they rank basically the reliability on a source based on different factors. And okay, after labeling the news like that, we could discover that on the left, this is the terminology mostly used, the top words used in the reliable set of news articles. On the right, there is the unreliable one. And we could discover that global warming is only present in the unreliable news. And usually, as we know from literature, global warming is a term associated with ox frame and less scientifically accurate contents. On the same column of the same group of unreliable set, we can discover also some conspiracy theory terminology, let's say, like man-made geoengineering, that refers to the fact that these news outlets probably were referring to a conspiracy theory in which hurricanes are man-made, basically, made in a laboratory. And on the contrary, on the reliable news outlet, the terminology shows reference like scientist or climate change or extreme events and whatever, that is a more scientifically accurate use of words related to hurricane and climate change. Okay. About the impact of the hurricanes of climate change, what we did is counting basically the tweets mentioning climate change before and after an event of a hurricane in the specific area affected by the hurricanes, all over the world in the blue line, except the specific area. And the yellow-orange line at the bottom is a random baseline that we use to assess the difference between impact on local areas, out of location areas, and random areas across the world. And we could discover that, in fact, hurricanes impacted by 80%, so they increased by 80% the mentioning climate change right away, the impact. But as I written here, this is a short life attention phenomena, because after a few months, nobody talks anymore about hurricanes, about climate change, sorry, nor in the affected areas, nor in the out of location area. And this was important because, of course, we developed this method to assess the impact of a specific event on some phenomenon or some timeline, as can be the climate change debate. And we observe also the notable shift in the terminology on news outlets talking about climate change. And we could provide some insights for policymaking or even climate change activist speech or whatever for the timing, so size the correct time when to talk about climate change and in which term talk about climate change, because language and timing can engage effectively the public audience into this topic. Again, I put here and paste here the QR code to the paper. I'd be happy if you want to have a glance on it. And yeah, that's it for the project. But now I want to ask myself and ask you, where did I want to go with all of this, and why I am interested in sports analytics and why now. So as I show you, I developed and I managed different projects, different methodology, different techniques to tackle different challenges during my project, during the PhD and during my first postdoc. And I trust that this methodology can be easily applied and expanded to the world of sports analytics, in which I have a current huge interest in, and I would like to pursue my research in this topic. And I'm not the only one having an interest in this sector, because I will show you very briefly, this is the topic interest in Google Trends in sports analytics over the past 20 years. And you can see it has increased, especially in North America, if you want the map. And also not only in academia, but also in industry. And as a testimony of this, I paste here a cool paper developed, the method was developed by DeepMind by Google for the Liverpool FC. That is a quite good team on the English Premier League. And in this paper, very briefly, DeepMind studied and developed a neural network able to, let's say, decide what's the best lineup in defense can be on corner kicks, basing the findings on the data that are private, of course, by the Liverpool FC corner kicks over the time. So this is just to have a glance and overview on everything that concerns sports analytics. And apart from that, sports analytics are pretty cool and fun. And with no further ado, I would like to show you a few projects that I developed in this past months. I will show you just two of them, because I think they were a good fit and most suitable for this presentation, because I involved in this project the same techniques that I talked to during the previous steps, let's say. And the first one is an analysis on temporal network, on the passing temporal networks of the two teams that got into the final of Eurocup 2016. So Portugal versus France. Portugal ended by winning the World Cup that year. And I will show you how tensor decomposition can give us, even if there are just some preliminary research, it's just like a early stage research, some good insights about team dynamics and similarity among players. The data used are public, so kudos to the group of Luca Papalardo. They did a very cool job storing and gathering all the data from this World Cup, this Eurocup, the World Cup of 2018, and some other matches from the Liga, the Premier League, and Serie A from Italy as well. So let's delve into it. Okay, so here I plotted the result of tensor decomposition on the temporal network of Portugal during the championship of Eurocup 2016. And as a reference, I put you the final lineup on the final match of the cup. And as you can see, tensor decomposition is quite able to capture both the temporal feature of this network, because in this direction, there is the activity of the player growing. So here we have the players that didn't much contribute to the passing network. And in this area, we have the players that were most central in the passing network. An interesting feature of this representation is that Cristiano Ronaldo, that I'm sure everyone knows in this room, that won also the Golden Ball that year, is central in this representation. And the MI means that is not only central, of course, in this representation, but is a trade union between all the players in the team. And another thing to notice is that I applied a simple K-means to individuate cluster in this representation. And as you can see, there are 7 different clusters. And you could say that the temporal network is quite clustered, of course. So there is a very different parts in the team, but where you see clustered, you can also see the flexibility of the team on the other side. And these things is in neat contrast with the other finalists, France, because same thing. So tensor decomposition on the temporal network from France. Here you have the lineup of the final as a reference. And same thing, so activity, these are the players that play the less in the top until the most important player in the passive networks on the other side. And the cluster here are just 2, so more compact team if you want, but also less flexible team. And you can notice how players like Sissoko, Pogba, Sagnac, and Shelby, sorry for my bad pronunciation of French, are in this side of the representation. So the right side with respect to the goalkeeper is on the left side here, and the other player like Payet, Titi, Evra, etc. are on the other side. So not only the temporal feature are captured, but also the structural one, if you want. So this is just a preliminary result, but you can see that it opens many possibilities to study. Okay, so for instance, I put here some future steps that might be interesting to investigate. We can have both a glance at team dynamics and similarity among players. And we can use this information, for instance, to predict matches outcome related on team dynamics, or also evolution of the structure of the team in time, or even understanding similarity among players. So similar players are embedding close in the space, can help us maybe understanding the market of football players. Okay. Related instead to the causal impact that I show you on the example of hurricanes and climate change, I would like to show you something about MBA and how this method is proven to be good to assess the effect of a given decision of intervention on a possible team or decision in the league or on a team per se. So what I did here is trying and understand how much LeBron James counted when he joined the Cleveland Cavaliers for the second time in 2014, because he was drafted and chosen by the Cleveland Cavaliers when he entered in the NBA, and then he left, and then he rejoined again in 2014. And we have the data provided by NBA, they are public, of all the points and the wins and all the other data about the Cleveland Cavaliers in time. Here are aggregated by month. And I use them as a pre-intervention and post-intervention data to assess the effect of LeBron James on this team. And we can see here that comparing the points scored by the team before and after LeBron James, and how the points scored would be in the case that LeBron James wouldn't join the team, and the point score actually scored by the team, we saw that the effect created by LeBron James was a 10% increase in the point score. Same thing for the wins. So the expected and the actual wins were different by 70%. So we have an increase in wins of more than 70%. But the very interesting thing here is that I evaluate also the effect of LeBron James on Cleveland Cavalier related to the plus minus. That is a metric adopted by NBA to assess how good of a lineup so let's say how good of a team they make against another team. So the plus minus before and without LeBron James would have been less than -2. So Cleveland were losing against any other opponents. While with LeBron James, we get almost plus minus of +4. So the effect on LeBron James of the team were more than 200%. And let's say that in Cleveland Cavaliers just won one finalist in the NBA, and LeBron James was on the scene when it happened. So we can safely say that this method can be inefficient in evaluating how a decision can affect a team. And it could be also a good way to understand if some players in NBA or in soccer or whatever can be underdogs. So not have the performances of other players, such as Steph Curry, LeBron James, Tim Duncan, or whatever, but can also make a positive effect while joining another team. On the other way, I would like to investigate it more because it could be a good proxy to understand if a player is not only a good player, but also a good team player. Okay, so I show you something that I did on other dataset, and I applied the same techniques or similar techniques on sports data. And as I show you, they can be, even if there are just some preliminary results, they can be very effective in understanding the team dynamics, the similarity among players, or the impact that a player or a decision can have on a team or on a league. And here, there are some interesting direction I already discussed with you during this presentation. The last things I wanted to add, this is another work I did on women NBA and the shooting success before and at the very last minute of the game of each quarter. And we can see that the shooting rate is neatly decreasing during the last minute. So these are very simple statistics, but it could lead to some analysis on the end game strategy of player, for instance, or classify players according to their end game strategy. And I think that this is it from me, and thank you very much for your kind attention.
Let's start in the room. I want to show some questions from online. Questions?
Question regarding the three projects.
Yeah.
Basically, when you showed us the modeling,
yeah.
Which tool did you use, like MBA or more Bertopic?
Bertopic, yeah, Bertopic. He was a very safe choice, and he helped us understand better the topics and the things discussed on the platform of Twitter during hurricanes. Yeah, no.
One about the context. Wait to that, yeah. Is it something about contact data that makes it especially amenable to this method working well, or can it be just other types of just arbitrary sample graphs that really count? So that because if you look at the 3D plot of by time, is it just that this method is going to pick up any arbitrary sequence of snapshot events and capture that time element, or is it something specific about context work?
Okay, so let me, maybe I was too in a hurry in explaining that. Oh, so basically the time is included in this weighted event graph is not, let's say, explicit, because what we have here is that the weight of the static event graph representation is the difference in time between two events. So you don't have the direct time at which events occur. So yeah,
and like as you're saying, so totally seeing that just reported into different.
Yeah.
Brain is very soccer passing network, but
yeah, that was the easiest choice, right? Because but both these vec dynamics, that it was more suited for studying dynamical processes on top of network. But even the tensor factorization that I show you more in detail also on the passing temporal networks, this is more suited for community activities of nodes in the network. So according to the goal you want to reach, there could be two different type of temporal network representation that might work out for you in different contexts.
questions. There's one on so I think so we can apply AI in football. One team player will guide real time by AI instructions through headphones. The other team will not get any guide and positive results in AI. In fact, or to predict results. I think I'm reading this correctly. It's about like result prediction via some of these techniques.
Okay.
Either in the literature or in your own work somewhere. Those things.
Okay, so in general, there have been several literature work. One of the earlier one was the one with from Mosteller that tried to predict the probability of winning a World Series in baseball, just having the just like predicting it on the base on the previous World Series happening in the years before, and just counting how many points difference there were between the wins of the two teams. So according to Mosteller, if we can individuate the best team, we can also with a very simple prediction individuate the probability of this team winning the World Series. And we don't need any information about the previous World Series, won or lose, apart from the games in it, won or lost by the best series. So this is just one example. It was very trivial, very simplistic, if you want, in treating the matter. I put here the predicting of the match's outcome as a possible extension work of temporal networks, because of course we can study the first half of a soccer match, for instance, understand the team dynamics, the strength and the weakness of a team, and try and compare it with the previous team dynamics, and compare it also with the previous outcomes, and try and predict it for the current match we are studying, for instance. But of course, there can be any other possibility about that.
You can potentially also aggregate each, instead of players, team, not all the league.
Yeah, sure. This can be, I mean, you can decide the granularity of it. You can decide similarity among players or even among teams and study, yeah, for sure. Yeah.
But one last question was just about a bit about how this type of research is done. So at universities, like what departments are typically doing this? Is this like a data science thing, or is it a business school thing, or
this temporal
like sports analytics broadly, but more of the new computational techniques to advance the
okay. I would say most of the leagues and teams and whatnot are trying now older shot with artificial intelligence, except for, according to what I know, baseball, that is still on the machine learning, network science, data science side. The other teams are just working more on artificial intelligence, not much in terms of modeling. This DeepMind paper that I put here was kind of an exception, more on the developing software to understand which player is acting in a certain way and at which time and whatever. So identification of games and game move and passes and players and whatnot. On the modeling side, I would say that data scientists, network sciences, and like people like us can really have a shot at it on the modeling side, because we can be more transversal on the sports and more universal in the result we might obtain.
Anything else? Okay, I think online is all set. So let's start again.
Thank you very much.